The Rhine is the most important waterway in Europe. From source to mouth, it links a number of large industrial centres. Along the river and in the harbours along the river are many discharge points of household and industrial wastewater. So the Rhine is heavily polluted. At the mouth of the Rhine is Rotterdam, the biggest harbour in the world. Rotterdam is first and foremost an important transshipment harbour. Each year, 250 million tons of goods are transferred for inland shipping to a large portion of Europe. Rotterdam and its hinterland need each other. In order to maintain depth, the harbour must be continuously dredged. 24 million cubic meters of sludge per year. But part of this dredged up sludge is heavily polluted with heavy metals, oil and organic substances. The discharged waste matter attaches itself to suspended matter, which then sinks in the harbour. This heavily polluted part of the sludge, 10 million cubic meters, can no longer be discharged at sea. Rotterdam has thus been forced to seek other ways to protect the environment. The decision was made to build a storage basin outside the dikes just in front of the Maasvlakte, the Slifter. For 1.5 years, enormous efforts were put into the building of the Slifter. In the coming 15 years, 150 million cubic meters of polluted sludge can be stored here. Millions of cubic meters of sand were moved with the help of 3 large press and suction dredgers and a number of bulldozers. The total cost 200 million guilders. Till shortly after the year 2000, 200,000 cubic meters of sludge will be dumped here every week. And then the Slifter will be full. So it is not only very expensive storage, but also temporary. Rotterdam is therefore looking for another solution to this problem. Cooperation is sought with the countries along the Rhine and the discharges to arrive at a clean river, so the sludge will not be so polluted and, as before, can be discharged at sea. In order to reverse the process of pollution with, for instance, heavy metals, Rotterdam has instigated a 3-phase plan. In the first 2 phases, research has been done into who is discharging what and in what quantities. With these research data, Rotterdam will be undertaking international negotiations aimed at the cleansing of wastewater discharges. The research into who is discharging what and in what quantities has been done by the International Centre for Water Studies. This independent institute for water research is specialized in research into wastewater discharges into surface water. It has developed a method for measuring the quantity of a discharge independently of the discharger, the independent load assessment. During the years 1986-87, ICWS took 2 research boats along the whole length of the Rhine and its most important tributaries for the purposes of this research. They performed an independent load assessment a number of times at the most important discharge points. What exactly is an independent load assessment? It is just a way of saying that the nature and the quantity of pollution in discharge water is being measured. It looks something like this. A company is discharging its wastewater into the Rhine via an underwater pipe. This wastewater is carried along by the current and forms a plume shape in the river. 3-dimensionally, it looks like this. In order to find out exactly where the plume is in the river and where the best place would be to carry out the load assessment, a number of surveys are carried out. The smaller boat, the Onrust, does the same upstream of the discharge point. Surveys are done by sailing straight across the river with the so-called measuring torpedo alongside in the water. The torpedo is equipped with a feathermeter and a number of electrodes. These are directly linked up to the computer in the lab. The torpedo can be hung at any desired depth by means of a crane. This plume has a higher electroconductivity than the river water. When the electroconductivity rises during the crossing, then we know that the measuring torpedo is in the plume of discharge. The Lehrer tells us at what distance from the bank this happens. The computer correlates the measured conductivity with the distance, and we get a graph of the position and breadth of the plume in the river. After careful evaluation of the surveys, the place for the load assessment is chosen. Then the skipper must position the boat exactly above the chosen spot. He is helped in this by the Lehrer. The skipper can follow the distances recorded by this device on a monitor in the steering cabin. The boat is firmly fixed in the desired place by lowering the anchoring pole to the bottom of the river. Now the measuring torpedo can be lowered into the water. Because the speed of the current and the concentrations in the plume vary, the cross-section is divided into segments. The torpedo now takes a sample and measures the current speed in each segment. All these measurements together form one load assessment. When the torpedo has been placed in the exact center of a segment, the load assessment can begin. At the same time, the Onrust also takes water samples upstream of the discharge point. This is necessary in order to be able to calculate the addition of waste matter to the river through this discharge point. A specially developed computer program processes all the load assessment data into a whole. Together with the water sample analysis results, we at last know which company is discharging what and in what quantity. If negotiations with dischargers fail to result in the cleansing of the discharges, Rotterdam Council may take legal steps. But we haven't got that far yet. In recent years, a lot has happened to reduce pollution. But in the first place, a clean Rhine is a matter of international cooperation. The will appears to be there, but it is a slow process. Too slow, because Rotterdam needs to dredge every day. Rotterdam is working on a clean Rhine, but it isn't only Rotterdam's problem. The pollution of the North Sea and the Waddenzee are also caused largely by the Rhine. In the end, a clean Rhine is a matter which concerns us all.